Okay, boys and girls, I'm Dr. Lo. So now we continue our lesson today. Okay, please get ready with your lesson number 5. Okay, boys and girls, basically we already complete the chapter 2. 1 and 2 already complete. So now we are going to entering the chapter 3. Okay, about force and motion. Okay, what is force? So today we'll learn what is force. We will learn different kind of force. Okay, so at here, force is a push or a pull. Like boys and girls, write it down. Push or pull. Okay, what is the unit for force? When we're talking about force, 10 Newton, 5 Newton, the unit is Newton. Okay, Newton. Capital letter N. Okay, Newton is the unit for force. Okay, a force can cause the following object. What is the effect that causing by the force? If the object is at stationary, that means that object is not moving lah. If the object not moving, we applying a force. Actually, we can make the object to move. So number 3 actually is the effect of the force. Okay, effect of the force. Or you can make the moving object, the object is moving, then we use it, apply a force and hold it, okay, to make it to stop. Make the moving object to stop, okay? Or we can change. So you look at this, the diagram, what does it show? We can change the speed and also change the direction. Okay, change the speed and change the direction. All these are the effect of the force. Okay, what else? It can change. Okay, we compress, we apply the force. Actually, we can change the shape, and we can also change the size, okay, of the object. Okay, how we measure force? We can using this spring balance. Okay, we can using spring balance to measure the force. One things that I didn't write at here, but I want to emphasize right now, they were trying to trick you. What is the effect of the force? All these are the effect. But one thing, it won't be changed. What is that? Mass is always unchanged. Okay, so boys and girls, you mark it down. No matter how the effect bring by the force, but force cannot change the mass. So what is mass? Later on, we will learn. Okay, we will learn about mass and weight. So mass is always unchanged. Even though we apply the force, it's still the same. Mass is still the same. So in the trial, in the past year question, they like to give you some option. One of the option is the mass, but actually mass is always unchanged. It cannot be changed by the force. Okay. So we go to your page number 2. Already finished writing down? Okay, can we go to page number 2? Okay, we go to page number 2. If I'm too fast, please let me know. Okay, boys and girls, number 2, page number 2, we will learn some important force. Force is a general name. So there is some specific force we can giving it special name. Okay, so at here we learn few different type of name of the force. Okay, the object is the pull. What object is the pull of gravity? Our gravity is pulling us. All the object, we will have a downward force. All object we will have a downward force because our earth center, our earth, the earth pulling all the object towards to the center due to the gravity pulling it down. So what is the name of this force? This force is called weight. Weight actually is a gravitational force. It's a force due to gravity. Okay, weight is a name of the force that due to the gravity. We call it as weight. Whatever object, we will having a weight pointing downward. You see, always pointing downward. Okay, when two objects they are touching each others, there is another force. The force at here we call it as normal reaction. Although in this diagram is writing contact force, but normally we seldom call this as contact force. We call it as normal reaction. Okay, we call this upward force as normal reaction. So this one, normal reaction. Weight normally we will give the symbol W, capital letter W. Normal reaction is depends lah. Sometimes writing as R. Okay, normal at here in physics, normal that means that 90 degree. Okay, So when two objects they are touching on the surface, so they will provide an upward force which is 90 degree. So at here, if I draw something like this, okay, here, I draw it here. Okay, this is the surface, this is the object. Okay, so this part is the part they touching each other. Okay, they touching each other. So 90 degree to it, which means that at here going up, upward force. Can you see that this is 90 degree to the surface? 90 degree to this surface. So this force actually we call as normal reaction. Okay, if I draw another case, something like this, slanted. Okay, with certain angle. So my object put at here. Now I'm going to ask you guys, I got four way of force. I label first. Let's say I say this is A. I say this is B. I say this is C. And I say here is D. Okay, boys and girls, can you tell me A, B, C, D, which one is my weight? Which direction of force is my weight? Can you type in the chat box there? Let me have a look. What is your weight? A, B, C, D, which one? Like any of you typing your answer on the chat box. What is your weight? A, B, C, D. B, wrong. Any others? A. Yes, correct. Right, boys and girls, A is your weight. Weight is always pointing downward. Okay, so this is your weight. This one is your weight, Okay, can you tell me B, C, D, which one is your normal reaction? A, B, C, D, which one is your normal reaction? There is an upward force, okay, which is 90 degree to the surface. Okay, it's an upward force provided when two objects touching each others. Yeah, thank you. The answer correct. D. Did you? Yeah. Okay, Xuan told us that D actually is the correct answer. D is a 90 degree. If I draw this one until here, can you see that it's touching to the surface and then here is showing 90 degree. Normal reaction actually is two objects that touching each others, and then it's an upward force provided by the surface. Yes, okay, it's 90 degree. Normal at here means 90 degree. Okay, so at here actually D is your normal reaction to the surface, 90 degree to the surface. This is a normal reaction. So normal reaction is actually one type of force acting upward when two objects touching. Okay, now I want to ask you a question. If a bird is flying in the air, is there any normal reaction? Now, any of you can answer me? If the bird is flying in the air, is there any normal reaction? Upward force, normal reaction. Call normal reaction. Any of you? Give me a response. Nine, dear. A bird flying in the air, is there any normal reaction? No, thank you, Megan. No, because the bird doesn't touching with anything. So normal reaction must be two objects that touching each others. Okay, so if the bird flying, no. Okay, but the bird standing, yeah, there is a normal reaction acting upward. Okay, from the surface, 90 degree to it. Okay, so we learn about weight, we learn about normal reaction. Okay, then here, another force that quite common called friction. Friction actually is two surface touching, then it can producing the heat. Okay, friction, it can producing the heat. So this one friction actually make our movement more difficult. It will always oppose our motion. Okay, it will always oppose motion. So at here we write down oppose motion. So you look at this, you are pushing in this way, this is your force. Then friction must be in opposite direction to your force. This is called friction. Okay, so you have to think about the question. You need to look at the question, which direction is our motion? Then friction must be opposite to it. Okay, so at here, friction act in opposite direction. Okay, then Friction must be two surface also touching and then producing friction. Okay. So air resistant. Air resistant sometimes we call it as drag. Okay. Air resistant is also one type of force. Air resistance is sometimes we call it as drag. Okay. Okay, drag or air resistance actually is one type of force, friction force, when they are moving through the air or water. Okay, if water we call it drag lah. Of course, we won't say air resistant in the water. We say water resistance. Okay. So next, okay, there is another force called upthrust. Upthrust. Okay, upthrust is an upward push of a liquid or gas. We call it as upthrust. Okay, thrust meaning like move forward. Okay, so at here, if there is a car, car like this. Okay, car. Okay, this is my car, cube car. Okay, if my car is moving in this direction, what is the force that make the car move forward? We call it as thrust. Okay, this force is provided by the engine. Okay, we start the engine, we press our accelerator, so car moving, this is called thrust. So at here, for the car, here we can have air resistance. Okay, with the tire, with the ground, we can have the friction. Of course, in the car, pointing downward, we have weight. Pointing upward, we got normal reaction. Can you see? Acting on an object actually can have a lot of forces acting on it at the same time. Okay? Then what else? Okay, one more force that I can mention at here is called tension. Okay, we can take some notes, extra. Tension. In future, when you saw tension, actually tension is also one type of force. This type of force is, where is it? For example, this is the wall. Okay, we hang something. Okay, we hang whatever the picture. Okay, picture here. So for this picture, so we have a downward force called weight. What force is pointing upward and holding it? This is called tension. Tension is a force that transmitted in the string, wire, okay, cable. This is called tension. Basically, all these are the name of the force that we will commonly use. Okay, we'll commonly saw in the past year question. Okay, tension is one type of force also. It's a force that transmitted in the rope, wire, or cable. Okay, until here, roughly we already have some idea about the force. Okay, different name of force. Any of you got any question? If no question, can you use the reaction button? Give me the response, then I know that we can proceed to the page number 3. Okay, no problems. Okay, like boys and girls, we go to next page, page number 3. Okay, force. We learn about force. So today, force it will divided into two type, two category. One is called balance force. Another one is called unbalanced force. How I differentiate balance and unbalance? Okay, that is depends on resultant force. Resultant force, or sometimes I call it as net force. It's the same thing, net force. Okay, for balance force, the net force must be 0. What does it mean? Let's say today, Chinese New Year, you receive ang bao. You receive 100 ringgit. Then after that, you play some game or whatever, you buy whatever that you like, you spend another 100 up. So what is your net money that you get? Answer is 0. You receive 100, then you go give up 100. So what is your net money? 0. So at here, force also the same. So we look at this example. Resultant force actually is a single force that has the same effect as 2 or more forces. What does it mean? Here we got 2 forces here. We got move forward thrust. Okay, the car moving forward is due to the thrust. Move forward, the force due to the force that make the car move forward called thrust. Then there is air resistance behind 600 Newton. So at the end, what is your net force? Okay, what is your net force at here? 600 Newton. They're acting in opposite direction here. They're acting in opposite direction, so we have to minus. Okay, if they are same direction, then we add. They are opposite direction, that means that they will cancel out. So at the end, what is your resultant force? 0. So the resultant force, maybe I can write like this, is equals to 0. This single force can be represent these two forces. We combine these two forces and then we get the resultant force. The final single force called resultant force, or I call it as net force. Okay, here, when the force acting on the object are balanced, you see, forward 600, backward 600, they are balanced and opposite direction. Now your resultant force is 0. So at this moment, we say that your force is balanced force, okay? Force are balanced. So when your force is balanced, resultant force should be 0. Okay? So that means that unbalanced force, your resultant force will not be 0. If 0, balance. If not 0, unbalanced. Okay? So you look at this. A box is at rest. At rest, what does it mean? It doesn't move. It doesn't move. When it doesn't move, that means that it balance. Okay, it balance. So at here, boys and girls, we look at this. R should be equals to W. R should be equals to W. They are balanced and cancel out each others. So when force are balanced, we will have two motion. Okay, last times we learned chapter 2, we already learned some motion. Okay, some motion, object at rest, moving with constant speed, accelerating, decelerating, and then what else? Roughly. Okay, so at here, when the force are in balance, we will have two type of motion. Either object as stationary or object moving with constant velocity. Okay, either it's in stationary or moving with constant velocity. If moving with constant velocity, it also balance. The force also balance. So look at here. Upward force must be equals to downward force. So your W, the weight, must be equals to your normal reaction. Okay, this R is normal reaction. Okay, your horizontal force must be balanced each others. Okay, so your thrust must be equals to your air resistance. And don't forget, here still got one more force called friction. So FF. Two condition, not two condition, it's two motion, two type of motion under force is balanced. Maybe object is at stationary or maybe object at moving at constant velocity. Okay, these two case. So when you saw this keyword, at rest, floating, okay, moving with constant speed, constant velocity, all these we need to know straightly in our brain. Net force is 0. Resultant force is 0. Force is balanced. Okay? Any question for balanced force? If no, then we go and see unbalanced force. Any question? No? Then give me response. Then I know we can go to page number 4. Okay, Megan, okay. How about others? Okay. Like dear, unbalanced force. If unbalanced, that means that it will have some value, okay, for your resultant force. For example, this is the object. Okay, here moving forward, let's say it's like 20 Newton. So maybe this one, total resistive force is 8 Newton. What is my resultant force? We will using bigger force minus smaller force. So at here, my resultant force will be in this direction. My resultant force, or I say net force, at here 20 minus x, I will get 12 Newton. Can you see that? I got resultant force. My net force is not 0. My resultant force is not 0. If resultant force is not 0, that means that this one, it is belongs to unbalanced force. Unbalanced force, the type of motion, we got 3 types. One is maybe object is accelerating. Okay, for example, just now in this case, maybe it is moving 600 and 600. Suddenly, I want to speed up. Okay, initially 600 and 600, forward and backward. Then suddenly I feel that I want to speed up. Okay, I want to speed up. So I press the accelerator. Okay, use my leg, press the accelerator. So my 600 at here, it will increase to 800 Newton. 800 Newton minus the 600 my resultant force no longer be 0. So at this moment, I can accelerate my car. So my car move forward, okay, with accelerating. So first motion is maybe because of the object accelerate. So maybe we can take some note like this. Voilà. Okay, draw a car, cute car. Okay, move forward. Let's say is 600 or just now 600. So it goes to 800 Newton. So this one we goes to 600 Newton. So my resultant force is moving forward, same direction of my motion. Same direction as my motion is 200 Newton. So object is accelerating. Another case is like this. Okay, just now here is 600 Newton. Backward just now also 600 Newton when they are moving with constant speed. But you imagine suddenly there is a strong wind blowing towards you, okay? Strong wind. So maybe here become 800 Newton. Strong wind blowing, okay? Suddenly got strong wind blowing. So your air resistance become increases. So at this moment, where is your net force? Your net force is oppose your motion. Your net force is 200 Newton, but oppose your motion. Okay, oppose your motion. Okay, at here, do you think that your car will move backward? Like any of you can answer me. If strong wind blowing towards you, will you move backward? You drive, then suddenly you move backward. Is it possible? Like any of you, give me some idea. What do you think? Will your car move backward? Give me some response, dear. Yes, How about others? My answer is no. It will make you slow down, but you are not moving backward. You will slow down. Okay, deceleration meaning slow down. So boys and girls, you imagine you are jogging. Okay, you are running in the competition. You are running. Suddenly there is a strong wind blowing you. You won't move backward. What? You just like very difficult to move forward. So you slow down. Okay, so for this case, number 2, another type of motion is possible is maybe object slow down. Just now it's maybe object speed up. Now it's maybe object slow down. No matter it's speed up or slow down, we need resultant force, okay, to make changes of our speed. This resultant force can make changes on our speed, okay. Another one more case is maybe object moving in circle. Circle is actually change direction. Change direction. If you want change direction, you need some force to let it change. The force called resultant force. Three case is under unbalanced force. Speed up, slow down, or you change direction. Okay? For balanced force, two possible motion is constant speed or maybe object at rest. It's balanced, okay? Okay, boys and girls, number 1, easy. Can you tell me what is your resultant force? Type your answer in the chat box. What is your resultant force for the case 1 and 2? Type 2 answer together, easy. 5 and 8. One correct, one wrong. How about others? Any others, dear? Xuan, yes, Xuan. 25 at here. You know why 25? Like boys and girls are here. Can you see? You have to look at the arrow of the force. You don't look at left side or right side. Okay, yes. They are both direction, same direction. The force pushing is the same direction. So at here, your net force or we say resultant force for this case, same direction, we just add it up together. So we get 25 Newton to the right. Okay, so opposite direction is easy. You look at it, which one is bigger force, then you minus the smaller force. Okay, so net force is 10 minus 2, you get 8 Newton to the right. Okay, so force, now I'm asking you, last time, did I teach you? I think I teach you about the, not yet, scalar and vector is okay. Okay, we will learn about one thing called scalar or vector. We haven't touched yet, it's okay. Okay, any question for this part? Then we go to the page number 5. Like boys and girls, 4 easy question, resultant force. Type your answer A, B, C, D. Then after this, we can do partial question. Okay, now it's just make sure you know how to count the resultant force. Return correct, A. Continue. Give me response, dear. A correct. B correct. C. C correct. D. Correct. Let me check others' answer. 6, 150, 83. Correct. Megan. Correct. Megan have to use capital letter. Unit for force is capital letter N. Okay, boys and girls, roughly got idea how to find resultant force. Okay, then now we are going to try with the past year question. Okay, you look at here. An aeroplane is in equilibrium. Highlight equilibrium there. Equilibrium means what? Balance. It balance. Okay. So at here, can you look at the diagram here? Which statement about the force is correct? Force from engine, what to the air resistance? Lift force from the wing, what to the weight? Okay, so try and then tell me what is your idea. Question number 1. You see the aeroplane at here, we say lift force. We cannot say normal reaction because it's flying in the air. Okay, but if landing, then yes, that is a normal reaction. Okay, so normal reaction must be two objects touching lah. The aeroplane touch with the ground. Okay, this question should be easy, what dear? Number 1, what is your answer? Force from engine, what to the air resistance? Megan, correct. How about others, like dear? Today, why you guys didn't give me response? Give me more response, thank you. Hui Tong, no. Half correct, half wrong. Balance. The force is balance. Emily is here. Today I didn't saw Emily. Like, give me any others? Give me one more answer. Then I will tell you the answer. Force is imbalance. Hui Tong. Xuan. You see, objects are balanced, okay? Force acting on the object are balanced. So you look at the force that I'm labeling at here. The upward force equals to your downward force. Okay, the forward force equals to your backward force. So we come back to this question, dear. Here, you see, the aeroplane is in equilibrium. When in equilibrium, the forward force must be equals to backward force. So your lift force must be equals to your air resistance. So these two correct. Oh, sorry, force from engine equals to air resistance. Your lift force must be equals to your weight. So your answer should be A. Is it okay, dear? If okay, then we goes to question number 2. Thank you, Hui Tong. Like boys and girls, goes to question number 2. This is 2008 partial question. A train is traveling along a horizontal track at constant speed. Right there, highlight the keyword constant speed. When we saw this keyword, the motion that dimension, so I understand this case, the force is balance. Okay, balance force. Right? Here they show you two forces that acting on the train. A force of air resistance also acting on it, so that you will getting a resultant force is zero. This question so kind. They tell you that resultant force is zero. Supposedly, they don't tell you, you also need to know force is balanced, then your resultant force should be zero. Again, then they tell you, I only label two direction, two forces. But actually, they still have air resistance. Can you tell me what is the value for air resistance and also what is the direction? Like boys and girls, try and then tell me your answer. Emily is here today. Shuan, correct. How about others? Wei Tong, try. Megan? Angelique? What do you think? Question number 2. Correct, Megan. Should be fine, right? This question should be okay, right, dear? Resultant is 0. Yeah, correct. Angelique, correct. So your forward is 60,000 Newton. Backward at here, you got 20,000. In order to make it become 0 resultant force, that means that we still have another force at here. In order to balance, so this one must be 40,000 Newton. Because at the end, from here is 60,000 to the left. Here, 60,000 to the right. It balance out. So your answer should be A. This question actually is trying to test on you. Do you know that constant speed actually is force is balance force? Okay, but it's still very kind, like you see, they tell you resultant force is 0. They can ignore this sentence and asking you to find air resistance. And then one more thing, the train is moving forward. Air resistance must be also opposed motion. So air resistance confirm is in this direction. Confirm. Air resistance also opposed motion. Okay? Like question number 3 here. This one you have to think. Some of my students they make mistake for this question, although question 1, 2 is correct. Okay, we look at this. An object is rising vertically at a constant speed through the water. I don't want to give you hints. Actually, you need to find some keyword. There are 3 vertical force acting on it. We got weight, we got drag force, we got upward force. Which diagram show the magnitude and direction of the vertical force acting on the object? I don't want to give you hints, but I want you to try first. Angeline, just now the question is A, correct? Because air resistance always oppose motion. So A is correct. Like boys and girls, number 3. Like try. What is the correct diagram? The force labeling is in correct way. You have to think what is the direction of weight, what is the direction of drag force, what is the direction of your upward force, and what is the magnitude is make sense. Right, boys and girls, try. You must try so that you are thinking and then you are learning. If I keep on giving you answer, actually the effect of studying is not that good. So please, we try and think first before I explain to you. Yes, correct, Hui Tong. Yes, correct, Megan. How about others? Vicious? What do you think? Vicious, I'm waiting for your answer before I discuss. No. No. Okay, like boys and girls, I give you some hints. Rising. Rising, that means that this is the direction of motion. Rising, that means that object is moving upward. If object moving upwards, If object moving upwards, your drag force must be moving downward. Because drag force is opposed motion. So if rising, that means that this is motion direction. Direction of motion. So drag force must be downward. How about your weight? Just now I told you weight must be always downward. Because gravity pulling one. So it must be always downward. Upward force, of course, it must be up. Upward direction. Okay. So at here, drag must be downward. This one wrong, oh. Drag must be downward. This one wrong, oh. Drag must be downward. Drag must be downward. So answer will be between C or D. Okay, then how we choose? Another keyword in this question is constant speed. Highlight, constant speed. So constant speed means what? Balance. Dear, balance. Balance force. So you look at C and D. Which one balance? This one, resultant force is this part, 4 Newton. This is 2 Newton. So resultant force is 2 Newton pointing downward. Then this one, net force or resultant force is, this part is 3 Newton. Here is 3 Newton, so your resultant force is 0. In this case, this is balance force. So in this case, this one is unbalanced force. Since it's moving with constant speed, so this must be a balanced force. Answer should be donkey. Okay, is that clear? If clear, can you give me response? If you are not clear, can you ask question in the chat box so I can explain to you? Okay, thank you. Like there, we goes to your page number 7. We goes to your page number 7. Okay. 2.1, show a cyclist traveling along a level road. So we got forward force, we got backward force. Can you describe the movement of the bicycle when the force shown in the figure 2.1 are equal size? The force are equal size. What is the motion? Type in the chat box. What is the motion? What do you think? How it moves? Is it object moving? It accelerating, decelerating, constant speed, not moving? Which one? What do you think? Any of you? What do you think? The size are equal. For example, here maybe like 50 Newton. Then let's say here 50 Newton. Equal size. What is the motion? Shown constant motion. Actually, you didn't describe what is the motion. We don't correct. Emily, you are here. Yes, Emily, finally. Just now I keep on calling you Emily. Megan, correct. So, dear, when the force are in equal size but opposite direction, meaning that your net force is 0. Net force is 0, that means balance. The force is balanced. Balance force, we got two type of motion. One of the motion is object at rest. Another one is maybe object moving with constant speed or constant velocity. Okay, boys and girls, why I cannot say object is at rest? Because you see, it's moving what, dear? It is moving. It's a moving, traveling. Keyword traveling. Traveling, that means it is moving. If it is moving, then it's not at rest. We say that it's at constant, moving with constant velocity. Is that clear? Now we goes here. This one later in the journey, the force start to change. Suddenly, I got some energy. Okay, I press harder, so my forward force is 225 Newton. Okay, at here, can you tell me what is my resultant force? So maybe that just now this one we can put 150 more easier. Pairing with the question below. 150 equals to 150. So this one you give some example in, number in, so that next time when you do revision, easier for you to understand. Okay, now 150 is the resistive force. It still maintain the same. But I press harder, so forward force is 225 Newton. Can you tell me what is my resultant force? And what is my direction? Correct, Hui Tong. What is the direction? Any others? How to find resultant force? Just now I let you practice few questions regarding finding resultant force before we comes to the partial question. So now it's the time for you to practice what is the resultant force and what is the direction. It's moving forward or backward? Forward or backward? This is the direction. Okay, right here. We're using big force minus small force. So 225 minus 150, your answer is 75 Newton. This is my resultant force. What is my direction? Forward. Or if you don't know, use the word of forward, you say that it is moving to the right. Okay? It's moving to the right. It's moving forward, dear, because this part is greater force. Okay, the forward here is greater force. So Megan is moving forward. This direction is forward. Here they say traveling forward force. So this direction is forward. And then this forward force is bigger. Forward force is bigger, it will move forward. Okay? Okay, boys and girls, so my resultant force is in this direction. If I want to ask you, can you describe the motion right now? Do you know what is the motion for these people? Okay. Can somebody describe and show me what is the motion? What do you think? What is the motion? Yeah, Shuan correct. Shuan correct. Megan correct. How about this? Okay. If your net force is in the same direction of your motion, if your net force is in the same direction of your motion, okay, your motion will be this. You see? Same direction as our motion. Same direction as our motion. So this one, the case is acceleration. If your resultant is oppose your motion, then it will make us slow down. So for this case, actually we can add one more question asking you, what is describe the motion? Okay, describe the motion of the cyclist at here. Answer is accelerating. Okay, how I know? Net force is not zero. It's unbalanced force. Okay, is that clear there? Is that clear? Good job. Okay, boys and girls, next page number 8, we will learn about mass, weight, gravity. So just now at starting, we learn about what type of force, what is force, okay, how force will give what kinds of effect. Then just now I got mentioned, they like to trick you, say that force can change the mass. So no. Why no? Okay, now is the time for us to study about this topic. Okay, before we go to mass, we go to weight first, because weight, just now we kept mentioning weight. Okay, so here now is weight. What is weight? Weight is gravitational force. Weight is one type of force due to the gravity pulling it. Okay, so why the apple fall down and hit the Newton test? Actually, it's because gravity pulling. So it will cause the apple have the weight falling down. So object fall because they are pulled towards to the earth by gravitational force. A force due to gravity called gravitational force. Okay, a force caused to due to the gravity. So can you see, no matter what object standing on the earth, actually it will having a weight which is pointing downward. Okay, like this, pointing downward from the surface, downward from the surface. Okay, then gravitational field. Gravitational field actually is a region. It's a region. This region, the blue color is the region around the earth where the object will pull and attracted towards to the center of earth. This region we call it as gravitational field. Then how strong of this gravitational field? We call it as gravitational strength. So on our Earth, our gravitational strength is 9.8 Newton per kg. This is a constant value that in the exam, they don't mention, but they expect you know. So this G, whatever formula involved with G, they won't tell you 9.8. They assume we already know on Earth is 9.8. Okay, so this is a constant value that you have to know. So this one, you can make a small star. You have to know this value. Okay, how we count how strong of the gravitational field? We're standing on our Earth's surface. How strong it is pulling us? Okay, this is called gravitational field strength. It's the force acting on 1 kg mass. Okay, so this is the way how we do calculation. Force divided by mass. The unit is force. Unit for force is Newton. Mass unit is in kg. So Newton per kg. Newton per kg. That's why on our Earth is 9.8 Newton per kg. Okay, for this patch, number 8, you don't struggle at here. This is just introduction to tell you that we are pulling by the Earth gravity and how strong of this gravitational field, the region pulling us. So on our Earth is 9.8. So don't struggle with whatever detail at here. This is just introduction. The most important actually is on your page number 9. Is it okay for your page number 9? Can we turn to your page number 9? Can we proceed? Give me response so I know that I can continue. Okay? Dana? So here, boys and girls, we look at here. Now, we have to differentiate between mass and weight. Just now we keep on mentioning weight. Then what is mass and weight? Different? Okay, so at here first. Weight is gravitational force. So again, what is weight? Weight is a force. Remember, weight is a force, okay? How we calculate the weight? W equals to mg. Mass times the gravitational field strength. That is my weight. And this G. And this G is 9.8 Newton per kg. Okay, as I told you, weight is a type of force, right? Force. So what is the unit for weight? What do you think? Any of you can answer me this question? What is the unit for weight? Right, any of you? Can you answer me? Okay, somebody answer me. Yes. KG, no. Weight is what? Look at what I highlight. Weight is what? Correct, Hui Tong. Weight, you see what I highlighted here? Weight is force. Weight is one type of force, okay? So at here, weight is in Newton. It should be in unit of Newton. Okay, weight is a vector quantity. I think we haven't learned about scalar or vector. Have we learned about this? Do you know what is different between scalar and vector? Chapter 2. Did I teach? I think yes. Is it? Vector quantity is the magnitude that we need to consider it's the quantity that we need to consider magnitude and also direction. Okay, direction for weight, weight always pointing downward. So weight got direction. It got direction. So weight actually is a vector quantity. Okay, until here, okay? Now I'm going down. So you can know the weight and mass, their relationship actually can using formula. This formula is very important. This formula is very important. Okay, now this is the table that I want to differentiate between weight and mass. So you look at here. My weight on the Earth is 560 Newton. My weight on the moon is 90 Newton. Okay, your weight on different planet will have different weight. It's because the weight is W equals to mg. The G is due to the gravity of the planet. On Moon, actually, the G is 1/6 of our 9.8. It's very small. That's why your weight only 90 Newton. But my weight is 560 Newton on our Earth. Okay, on our Earth. So my mass is always 56 kg. At here, actually, this diagram is the O-Silver's diagram. That's why from the mass to the weight at here, mass is 56. W equals to mg. Why they get 560 is because 56 is because last time our old syllabus, our G is using 10. But starting from 2023, we are new syllabus, so our G have to use 9.8 Newton per kg. This diagram actually is old syllabus diagram. That's why they told you mass is 56. My weight on Earth is 560 Newton. It's because they are using G as 10. Okay, now boys and girls, what is the unit for mass? Write it down, kg. We measure mass in kg. We measure weight in Newton. Then mass. Do mass have any direction? My answer is no. It don't have direction. We say 1 kg, 2 kg, 3 kg, 4 kg. It doesn't have any direction. So it's scalar quantity. Weight is vector quantity. Weight have to consider direction. Okay, here weight is a force. It's a force due to gravity. We call it as gravitational force. Okay? Mass. What is mass? Amount of metal. What is the meaning of amount of metal? For example, now I got 3 chop at here. Okay, this one is I chop. Use it to chop my students' worksheet 1. 1, 2, 3. On Earth, I got 3. 1, 2, 3. This is called amount of metal. I bring this to the moon. Okay, I bring this to the moon. How many do I have? Actually, I'm showing in front of my camera. 1, 2, 3. I go to the moon, I still have 1, 2, 3. This is called mass in physics. So this mass is not your real life mass. Okay, mass in physics is amount of matter. Okay, amount of matter. We bring 3 objects, okay, 3 chalk, okay, stamp to the moon. I still having 3. 1, 2, 3. That is mass. Okay, the second point talking about the mass is the mass actually will resist the change in motion. If your mass is big mass, you want to push, not easily to change the object. If the object is at rest, imagine that is a lorry. You're trying to push using your hand, okay, trying to make the lorry to move. Easy or not? No, because it's big mass. So mass actually got property to resist the change in motion. So this one in future we'll also talking when it's related with the inertia and also Newton's first law and second law. We'll talk about this. Okay, so this one actually is two things. So mass is amount of matter. No matter how, it won't be changed. You have to keep in your brain. Mass of an object is always constant everywhere. Constant. This is a very important point. That's why I told you starting page number 1. I say what is the effect due to the force. I want to emphasize the force unable to change the mass. Mass always constant. Okay, mass is always constant. How we measure mass? We can using balance. How we measure weight? We also can using balance. They can using balance to measure the weight. The weight. Just now mass cannot be changed, what, right? But weight will change. Why weight will be changed? W equals to mg. Because weight is affected by gravity, gravitational field strength. So this value on Earth is 9.8 Newton per kg, but on others planet it might be others value. So it depends on your G. The weight will changing with the magnitude of G. It depends on G. Okay, until here, is that clear? What is the difference between mass and weight? Like boys and girls, is it okay? If okay, give me response. If not okay, you type your question in the chat box. Is it okay? Okay, Okay, dear. Now I want you guys try with the past year question. Give me 2 minutes. I goes to the toilet for a short while. Is it okay? You try with the past year question. Then after that, I come back. We can discuss. Is it okay? Thank you. Okay. Hi, I'm back. Okay. Can we discuss? Okay, we discuss question number 1. Which statement about mass and weight is not correct? Right, dear? Give me your answer. You should be able to type, right? Type your answer and show me. Question 1, 2023, 2 years ago. The past year question. My boys and girls, tell me what is the answer? Emily. No, Emily, no. Megan. Oh, sorry. Emily is correct. Emily is correct, dear. Emily is correct. Like, dear, is not correct. This question asking you not correct. So answer should be what? Answer should be B. Mass is not a force. Actually, it should be weight is a force, not mass. Okay, the rest are correct. Emily, you are right. Okay. Like question number 2. Which object has the greatest weight? Weight formula, W equals to mg. Now they give you different g. So you have to using the mass times g. What is your answer? You have to get ready with your calculator. Every physics lesson, you need to get ready with your calculator. You need to do calculation. Okay, like boys and girls, number 2. Give me answer. Then we can proceed. Boy, correct. Thank you, Megan. Answer is boy. Okay, so you have to count by yourself. 150. This is the weight. Weight is Newton. Okay, Newton. So the rest you count by yourself. Okay. Number 3. About mass and weight on the earth, which one is correct? Now it's asking you correct. What is your answer? Any of you? What is your answer for question number 3? Mass and weight, which one is correct? Oh, you haven't reached to this question? Somebody answer me. Thank you. Y10 B. Answer B, correct. Large object doesn't mean that you having more mass. If cotton, a big cotton, but it doesn't mean that you have more mass. So this one is wrong. We don't know. We cannot make such conclusion. Okay, so balance can be used to compare weight and also mass. Both can. Okay, mass is a force. This one is wrong. Mass is not force. Weight is a force. Weight is a force. So answer is B. Okay, then we go to question number 4. Is it okay? Am I too fast, dear? Can we proceed? Number 4. Have you tried already for question number 4? This question I wish you to try before we discuss. The weight 3.5. G 7. Gravitational field strength on the Earth is 10. 10 is because this is old syllabus. Old syllabus before 2023. Before 2023. This is 2017. Past year question 2017. So the G we're still using 10. But right now, you have to know we are using 9.8. Okay, by the way, any of you able to do calculation for question number 4? Can you tell me your answer? None of you done for this question? Qinyu, let me have a look. Yes, correct. That means that if you're able to answer this question, that means you understand the most important key point about mass and weight. Good job. How about others? Hui Tong also give me the answer, right? Okay, like dear, above the earth. Okay, above the strength at the height of the, what is that? Space core. Okay, above the earth. So this one is 7 Newton per kg. W equals to mg. They say that the weight is 3.5. But I don't know. I don't know what is the mass. I don't know. So mass, I keep it. I want to find mass. So this one, the new g is 7. So I will find and get it 0.5 kg is the object mass. And just now I keep on emphasize the mass is always constant. Okay, it's always constant. So at here, now we want to find the mass 0.5. Even on the Earth's surface, it's still 0.5 kg. No matter it's above the Earth or on the Earth's surface is the same, okay? The mass won't be changed. How about the weight? Weight is depends on your G. Now your G become 10. So it will become 0.5 times 10. So it will be 5 Newton. So answer will be B. Okay, 5.0 lah, because we want to always make our final answer in two significant figure. 5.0 Newton. Here, there is a key point is, do you understand the mass? It will be the same. So on Earth, on Moon, the mass will be the same. You just change your G according to the planet or according to the gravitational field strength. Okay, so if you're able to answer this question, that means that you understand the important key point. Okay, until here, question 4, is it okay? Give me a response. If okay, then we will go to page 11. Thank you, Megan. How about others? Okay, we thought okay. Okay, dear, we goes to your page, Qinyu. Okay, thank you. Now, we goes to page 11. Read the question. Gravitational field free fall. Actually, it depends on your gravitational field strength lah, the G lah, okay? G on Earth is greater than the G on Moon. Okay, continue. I give you the hints already. Compare how do the mass and weight compare on the Moon and on with the Earth compare. Okay, number 5, you try, think, and then try to give me answer. Don't be shy that you make a wrong answer. It's okay. Because in learning process, we need to make mistake, then we learn from the mistake. Then we understand the concept. So don't be shy. We don't know each other's what, right? We didn't see your face. You see my face only. So don't be shy to give me your answer. It's okay. If you give a wrong answer, that's fine. My boys and girls. Any of you? Answer? What is the mass of the space rocket and what is the weight? Shu En. Mass correct, weight not correct. Emily, also the same, Emily. Mass correct, weight not correct. How about others? Shu En, yes. How about others? Okay. Like boys and girls, mass, you always think that same object. Now we are talking about the space rocket. It's the same object. If same object, the mass will be the same. This one is for sure. Okay, let me have a look. Megan, no. You also the same. So that means that you all having the same idea, same concept. Okay, look at here. W equals to mg. On Earth, if I talk about on Earth, my G is greater. Okay, my G is greater than my G on the Moon. Okay, so at here, if my G is greater, my G is greater G. What's going on with my weight? In mathematics, W equals to mg. My G is a big value. Then what happened to my W? It will increase, am I right? On Earth, actually weight is higher weight, greater weight. Do you agree? On Moon, W equals to mg. My G at here is small g, smaller than Earth. So my weight also smaller. It should be weight on the Moon is less. Weight on the Moon is less than the Earth because of G of the Moon actually is small g, smaller g. So just now, Shuan, Emily, Megan, is that clear for this? I think maybe you think that this is weight on the Earth compared to the Moon. I don't know. But do you understand about the concept? The weight on the Moon will be less. Do you able to understand about this question? Yes, Megan. Okay, dear, maybe I can show you this. See this? My weight on the moon is around 90. My weight on the earth is 560 Newton. Why? It's because my G on the moon is a small g. It's a small g, okay? Then this one is actually a bigger g. So on the earth actually is higher weight. This diagram can show you the answer. So is that clear for this part? Any question? Any question there? If no question, give me a response. Then we goes to question number 6. Okay, Chinyu say okay. Then we goes to question number 6. Okay, a sphere P made of steel has a weight of 10 Newton on the Earth. Okay, another sphere Q also made of steel has a weight of 10 Newton on Mars. Oh, they're having same weight, but they are on the different planet. So their G is different. So they tell you that the G on the Earth is greater than the G on the Mars. Which statement is correct? My dear, read A, B, C, D, and then you tell me your answer. Try and think. G on Earth is greater. It gives 10 Newton for the weight. G of Mars is smaller, but it also gives the weight of 10 Newton. So you think and compare their mass? Any of you got an idea? How? Megan, give me answer. Let me have a look. No, Megan, no. Think again. Will they having the same mass? They get same weight. W equals to mg. But the g on Earth is greater. The g on Earth is greater. Chinyu, correct. Okay, Chinyu, give me the correct answer. Answer should be B. Dear, answer should be B. Why? Okay, C and D actually we can cancel lah. We can just cancel this answer C and D. Weight of the sphere P is more than 10. No, they already told us. P is 10 what? They already told us, so this is wrong. On Earth, wait. On the Mars, okay, W equals to mg. If on the Mars your g is smaller, then how your weight is become greater than 10? No, your g already smaller, so you won't be able to get the 10. Okay, it will be less than 10. Okay, on Earth, your Q will be less than 10. W equals to mg. On our Earth, our this is higher. That means that your Q, object Q, this is object Q, this is object P. Okay, this object Q, it should be get a higher value because the G is already increases. So it should get greater than 10. C and D confirm wrong. Okay, confirm wrong for C and D. So the mass it not be same is because 10 Newton here for the weight, 10 Newton here for the weight. Then how your G become, how your mass become the same? This one on Earth. This is on the moon. So the moon actually having a smaller g. This g is smaller. This g is higher g. So that means that your mass of your P at here actually is a smaller value. Smaller value times a bigger G, you get 10. Then this one, your mass of your Q actually is a higher value. So the higher times the small g, you get back 10. If you still cannot understand, then we simply put some value lah. Okay, we simply put some value. W equals to mg. I know on earth is 10 because this is 2020 lah. Okay, it's not a current past year question, current syllabus past year question. So we put 10 first lah. Okay, easier for us to do calculation. Then the weight is 10. So what is your mass? Mass is 1 kg. Okay, on the Mars, W equals to mg. Oh no, not Earth, not Moon. Just now I keep on saying Moon. Okay, Mars. I know that the G on Earth is greater than G on Mars. So at Mars at here, I can simply put a value. Let's say I put 1. I don't know what is the value, but I put 1 smaller than 10. Then what is my mass? And this is 10 Newton. So can you see that your mass for the Mars is Q, object Q. Q. This is P. The object on the Earth is P. Object on the Mars is Q. So you see 10 Newton. From here, we're trying to put some value in to see the relationship. Although I don't know what is the G for Mars, but I know that the gravitational field strength, the G for Mars is smaller. Then I can put any value, I can put 5. Also can, no problem. So at the end, you will find out that what? What conclusion we can make at here? Can you see that? The mass for PE must be greater, smaller. Smaller than the mass of Q. So they won't be the mass of the same. Their mass won't be the same. No, they are not the same. Mass P is less than mass Q. Mass P is less than mass Q. So your correct answer should be B. Is it okay? Then, since we're using value already, I can go to, you continue using our value to go and see the C. We go and see the C. They say that on Mars, W equals to mg. The G is Mars lah. Okay, we're using the mass. Let's say, because just now I substitute, the mass is 1. 1 Newton per kg. So at here, it should be 1. Okay, what is the mass of P? What is the mass of P? 1 kg, because here, I'm using the mass of the QP at here. So it's 1 kg times the mass. Just now I set here as 1. So now I'm using 1. You see what is the value for the weight? It's 1 Newton. It should be less than 10 Newton. It should not be greater than 10 Newton. We're trying to put some value to help us visualize the question. Visualize the question. You can put, why teacher, you put 1 for the Mars, you can put 5. 10 divided by 5 more easier. 2 Newton. Okay, 2 Newton. Wait, why I write Newton? Mass is in kg. None of you realize? This is kg, okay? This is kg. Okay, then we can also try with the D. The weight of the Q. This is Q. That means I'm using object Q. On Earth, that means this is the G on Earth. On Earth, at here, we're using 10. Of course, new syllabus, we're using 9.8. Right now, we're using 10 is because easier for us to do calculation. This one is helping us to visualize only. So what is your mass? Mass for the Q. Q is 10. So 10 times 10, you get 100 Newton. So it should not be less than 10. It should be more than 10. Should be more than 10 Newton, yes. This one need a strong understanding. You're only able to answer it. But I trying to put some value to help you visualize the question. Okay, on Earth G, I put 10. I want to put 9.8 also can, but I need to do some calculation using calculator. But I put 10 is easier for me to do calculation. So 10 divided by 10 is 1 kg. On Mars, I know question tell me the mass G is smaller G. So I can put 2, I can put 5, I can put 1. Doesn't matter as long as the value that I put is less than 10. Okay, and easy for me to do calculation. So in this case, I put 1. 10 divided by 1, I found out that my mass for the Q will be higher than your mass on your object P. So from these two part, I can make a conclusion. Object P mass is smaller. Object P mass is smaller. Okay? This question not that easy, but if you understand the concept, you only can answer this question. Okay, I let you digest for a short while. Any question you want to ask? If you are shy, you can private message Newton Scholar. If you message the Dr. Low account, that is my iPad, so I won't be look at the chat box because I'm use it for writing. So you have to message me to the Newton Scholar. So you can type it out. What is the part that you not understand before we proceed to the last question? If you know question, then you digest for a short while for this question. C and D are also helping you to visualize by putting the value just now go in. They say weight of sphere P, so I using the mass of sphere P. Then on Mars, so I using the G from the Mars. So I get 1 Newton. Then D, I get more than 10 Newton. Any question? Ten seconds for you to ask me question. If no question, we are going to proceed to the last question. If you already clear about this, then you give me response. Reaction button there. Pleasing only, easy. Then I know that we can proceed. Megan okay Qinyu okay? How about others? Hui Tong? Emily? Hui Tong okay? Emily? Okay, Angeline, Licious okay? Emily okay? Xuan? Xuan? Or Xuan? Okay so this question clear Okay clear Then last question easy. Which statement, this is 2020 question, which statement correctly describe the effect of placing a heavy load in a car? Okay, heavy load in the car. Read the question A, B, C, D. Which statement can be correctly describe the effect of having heavy load? Tell me the answer. If you already get the answer, then you tell me the answer. A, B, C, D. Emily correct. Xuan, no, Xuan, almost there. Think again. You can think about heavy load in a car. You can change to other things. For example, the elephant, okay, running towards you, or elephant is stopping, standing. You want to make it move. Or the elephant is running towards you. You want to stop it. Hui Tong correct. Xuan can think one more time. Megan, Megan, now tell me the answer. Or you can think about Megan. No, Megan, no. Or you can think about you go to the shopping mall. There is a trolley. Starting trolley is empty. Is it for you to push and make it accelerate or not? That means speed up. It's empty, so you just push only, then it speed up. Okay, you want to stop it easy or not? Empty, small mass, hold it, then you stop. But if let's say right now, okay, you're already full with the rice, the powder, whatever powder, milk powder, okay, this detergent, liquid detergent, and so on. Now you're trying to push it. It's at rest. You're trying to push it. Easy or not? Not easy. You are difficult to accelerate it. And once it's already start to accelerate, you want to stop it. Easy or not for you to stop? So you imagine, easy or not for you to push the lorry to move? And easy or not for you to stop the lorry by using your hand? Malaysia is power of hand. Easy or not for you? My answer is not. So answer actually should be C. It will be difficult to accelerate when greater mass. It will be also difficult to make it rest, okay? It already moved, then we want to make it rest. It's also very difficult if the mass is big. Okay, why is this answer? We have to go back just now the definition for the mass. Just now comparison the mass, you see here. Properties, this sentence, properties that resist the change in motion. Object want to change the motion, for example, at rest, it want to move. Easy or not? If your mass is high, it will resist to move. Okay, if your mass is high, if object is at rest and the mass is high, it will resist to move because it don't want to change, resist to change the motion. But if the object is large mass and is already moving, you trying to stop it, not easy. Because it already moving, it resist to change the motion. So this one, the mass is actually having the property that resists to change. Object at rest, it will trying to still at rest. Object moving, it will trying to keep the motion as moving. So for the last question at here, answer should be C. If it is at rest, it is difficult for you to accelerate it. But if the object is already moving, you want to Newton per kg. But of course, in before 2023, we are using 10 Newton per kg. Okay, is that clear for my explanation for question number 7? Give me response. Okay, How about others? Hui Tong, okay. Others also okay. Okay, good job. So dear, our lesson today will be stopped at here. Any question? If you're facing problems, then you can message me also in the WhatsApp, okay?